Okay, test. Okay, guys, now we go to the example of angular quantities. You see the question here. Carousel is initially at rest. At rest is initially at rest. That means what? That means omega 1 equal to 0. Okay. At t equal to 0, it is given a constant angular acceleration alpha 0.06 radian per second square, which increases its angular velocity for 8 seconds. At 8 seconds, determine the magnitude of the following quantities. A. Angular velocity of the carousel. B. Linear velocity of a child located 2.5 meters from the center. C. Tangential or linear acceleration of the child. D. Centripetal acceleration of the child. And E. The total linear acceleration of the child. Okay, A is angular velocity of the carousel. Angular velocity of the carousel means you have to look for omega 2, right? As you know, in linear velocity, the formula is in linear v equal to A. In linear velocity, the formula A equal to v over t, delta v over delta t, right? So, in the case of angular, it's similar, alpha equal to omega, sigma omega, delta t, or equal to omega 2 minus omega 1 delta t. Okay, omega 1 is 0, so omega 2 is the one that we're going to look for. Delta t is 8. Okay, alpha is given 0.06, so you can find from here, let me write here. So omega 2 minus omega 1 equal to alpha delta t. Omega 1 is 0, so omega 2 is equal to alpha delta t. Alpha is 0.06, delta t is 8. Okay, so you will get around 0.48 radian per second. Okay, that is for A. For B, linear velocity of the child located 2.5 meters from the center. Linear velocity of the child. Linear velocity of the child is V. We already found omega. So according to the table just now, yesterday, discussed, relation between V and omega is V equal to R times omega, right? What is R? R is the 2.5. Omega is 0.48, right? So it's around 1.2 meter per second. Okay. C, the linear acceleration of the child. Linear acceleration, A. It's also straightforward. Angular acceleration is given alpha, right? So according to the formula, A equal to R times alpha. R is given 2.5, 2.5. Alpha is also given 0.06, right? So it's around 0.15 meter per second square. Okay. D, centripetal acceleration of the child. Okay, centripetal acceleration of the child. So beside the linear, because this is a motion, a rotational movement, circle path, the motion is a circle. So beside the linear acceleration and angular acceleration, it also have, they call it centripetal acceleration. So the object will keep rotating, right, at the path, the circle path. Centripetal acceleration. The opposite of centripetal, they call it centrifugal acceleration. So the formula will be A R equal to V square over R. We already have V just now is 1.2, R is 2.5. So it's around 0.5658 meter per second square. Okay. E, total linear acceleration of the child. Total linear acceleration of the child. So we have a linear tangential, and just now we have centripetal acceleration. Okay. So by using Pythagoras law, so you will get total linear acceleration. I write here equal to A tangent square plus A centripetal square. Okay. So A tangential, answer of C is 0.15 square. Centripetal is, we just get it, 0.58, right? 0.58 square. So if you calculate this one, you will get around 0.6 meter per second square. Okay. You can also find the direction by finding the theta. Theta equal to inverse tangent of acceleration of tangential over acceleration of centripetal. Okay, so inverse tangent of acceleration of tangential is 0.15, acceleration of centripetal is 0.58. Okay, so you will get around 0.2525 radian in radian. Okay, so A is angular velocity, omega 2, B is linear velocity, V, C is tangential acceleration, A tangential, D is centripetal, AR, E is a total linear acceleration. Okay, we go to the next example.